Thank you all so much for your patience. Who knew plugging a laptop in was so difficult? Now, as you all know, agents are all the rage, and we're going to try and speed this up a little bit, and we'll see what of the demo we can actually cover. But one of the key things that I want to highlight, you know, everyone's talking about agents, everyone's trying to deploy them in production, and some are getting there, and that's fantastic. But one of the key differences between agents and chat scenarios is the sheer volume of tokens they consume. They're doing a lot more of the thinking and the acting on behalf of us all as we offload these capabilities to the cloud. And as a result, not only are they extremely capable, but the costs are increasing as you scale the agents in production. So one of the things that we're going to teach you today is how to use Foundry to facilitate fine-tuning these open source models that are smaller, that are extremely capable once they learn your business domain, once they learn what you define as being good. And they can do this at a small fraction of the cost of the frontier models. Everyone's tendency is to grab the latest model as it gets released by a large frontier lab and put it in their agents and use prompt tuning to facilitate actually achieving your scenario. And that works. These frontier models are incredibly capable.
But the thing is, it's not connected.
However, oftentimes, the order of the tool calling in an agent matters. The policy adherence matters. And the rate at which those tools are called can substantially increase the overall latency as well. And so one of the ways that we want to shift your mindset and help you think about scaling your agents in a secure, scalable, and trustworthy way is by defining your evals first. This is almost like test-driven development for the age of agents. By defining your evals, you can specify what is good, what your policies are, how the agent should behave, which tools should be called when. And all of this can be done in a consistent and repeatable way, regardless of which models you're using in the agent. So you can define your quality bar, and then as you're swapping out, trying different models, whether it's the latest frontier model or a small open source model, your evals are the thing that help you determine whether your quality is sufficient to be able to ship to production. And that's the key thing. Is like evals are not something that you should be doing at the end of the process. You should be defining them up front and then iterating on them while you're iterating on your model and iterating on your agent. And so with that, we're happy to announce that now Foundry not only enables creating agents and deploying agents, but also enables customizing those agents using any open source framework on any open source model to achieve the level of quality that you need to ship to production. Now, I'm going to show you a bit on how we can leverage Foundry to achieve that. Now, I've got Foundry, and I apologize I didn't warm this up because we were clearly planning on using the other laptop. But we've got a chatbot scenario, and I'll show you with a couple of custom models here. Now we've got the GPT 5.2 frontier model, extremely capable model, and here I've got a customer service retail agent which is going to interact with the customer and operate against my data, my policy, my business domain. GPT 5.2 inherently doesn't know anything about it, but it's extremely smart, and given that I've added 4 specific tools to this agent, it's going to reason over how to interact with these tools, to connect with my data source behind the scenes, and be able to actually validate how it should interact. Now, while that's running, I'm going to go ahead and use an open source model as well, Quen321B. Now, this model can operate at 1/10 the cost of GPT 5.2. It's a small, very efficient model. It's a very capable model. And again, it's able to make some pretty good guesses as to how to work with the tools in this particular agent. However, as an end user, a customer, interacting with the agent, I don't really want a bunch of questions back at me. I just want resolution to my scenario. And so by fine-tuning this open source model using reinforcement learning techniques, you can choose to train the model to not only understand your business domain, but also understand how to use the different tools in what order to achieve the maximum benefit for the customer, your company, and do so at the lowest cost possible. But how do you even get a data set to be able to facilitate doing that reinforcement learning? Well, one of the things that we've launched in Foundry recently is the ability to not only dig into how these models and agents work together to look at the specific traces, so every single session, every single interaction with your users is automatically captured, and that observability, including not only the reproducibility to understand, oh, let me learn how it behaved, but the cost, all is automatically captured. We can dig into the specific traces of any specific session automatically, and we can see here that it's not only invoked the model a couple of times, but it's also invoked the tools that enable the agent to perform well, to do the order lookup, to validate against my policy. And ultimately, these models can then interact with all those to get the right outcome for the customer. But we can also take all of these traces from the models and the agents running in production and automatically convert them to a data set that we can use for subsequent reinforcement learning to improve the behavior over time. So we can select all of the sessions that have been executed against any of the versions of the models, generate this training data set, which you can then use for subsequent reinforcement learning. And once you do that, then you can get the ideal model's responses for your business. You can train at which of the traces are useful, use that data set, and invoke subsequent reinforcement learning training runs. So this is where we're headed. And Vijay, do you want to walk us through the slides at least? Unfortunately, we can't do the demo in the demo session on how we're going to get there.
So thank you, Chris. Can you guys hear me? Okay. So everybody has heard of model customization, fine-tuning. You also heard of reinforcement fine-tuning, I guess. So what is post-training? Everybody knows what either of the terms are, but post-training basically is a broad umbrella term where you take any data that you need. That data could be custom data that you have, agent traces that you have, or data that is distilled from larger models, or something that is synthetically generated. So you basically spend significant amount of time prepping your data. Potentially up to 80% of the time, you prep the data, and then you basically change your model behavior using various techniques. And the techniques that we talk about are things like SFT and RFT broadly, but there are other techniques. But in this case, in this example, we're only sticking with these two techniques. So basically, you do distillation using traces, and then you do SFT, and then you do RFT. The reason why you do SFT, and the reason why you do customization, like Chris said, it's all about token efficiency, your performance, and your accuracy of your tool calls. So the agents actually are effective, and you get the ROI for the investment that you have. So let's go back to I kicked off some jobs. So let's see. So there are some jobs that I kicked off before the demo. Let's say there is a SFT job, there is a supervised fine-tuning job, and there is RFT job. So RFT here, the difference between SFT and RFT, SFT is basically teaching the model how to imitate what you give. RFT is the one that's saying, here are the verifiable steps. As long as you make sure that every single one of the steps that you follow and you get the task done, that's what you need to do. That's what you reward. So it's basically 0 or 1 or something in between. The closer you are to 1, that's when you're saying that the model is closer. So it's basically, it's more verifiable. So when you kick off the job, you have, let's say, native integration with Ray dashboards, and we have your rollout browser. So when you have a Ray cluster, so you can basically, in Foundry, you can manage everything else. Let's say this is custom code. You bring in your code, you do your GRPO, you bring your model, and when you're doing a Ray cluster, you can manage the entire Ray cluster here. It's an AAD authenticated endpoint where you can basically look at all your CPU nodes, GPU nodes, everything in between, and then monitor the job. And then the rollouts specifically, yeah, like in a minute. Yeah. Okay. So, sounds good. So this is the trajectories in RFT. So you can basically see for every sample that the model is going through, all the samples, all the tool calls, and everything else is doing, you basically are rewarding these tool calls specifically, which basically says, hey, if you're doing this specific method, it's okay. If you're doing this, you're punitive, so on and so forth. So basically, you can watch the reinforcement fine-tuning in action till you get to the reward thing. And the last thing here is if you see a so the last thing here is we just want to show that when you do that, you can basically have better results with SFT and RFT. Thank you, folks. Thank you for all the patience and the delay here. Thank you.
Thank you so much.
Find them somewhere.
Yeah.